All right, last section we have for the next hour. So, part 15, power factors. Power factors. All right, so like in DC circuits, we had power, which was I. Power equals volts times amps. Well, we have power factor in AC circuits, but they're a little bit different. So here we go. So there are two types of power used to describe work in an AC circuit. I'm gonna give you two. So there are two types of power used to describe work in an AC circuit. There is true power. True power, which is in watts. It is defined as the actual amount of power consumed by resistance, not taking into account inductance or capacitive. So true power watts is the actual amount of power, is the actual amount of power consumed by resistance. Consumed by resistance. I'm just going to big R, resistance. Then I'm going to write it out because I decided to. Which is to say, not from XL or XC. Measured in watts. Which is also P, symbol P. The formula that you will want to write down is power total equals I squared times R. I squared R. I squared times resistance. Then they have apparent power.
Does that stick consumed by resistance or resistance?
Consumed by resistance. Well, you're way back there.
I mean, I'm not as fast as you.
What are you writing legibly or something?
Is it effective?
What?
I effective? Yes, I effective or I P2P?
That is a good question. We'll get back to you on that one. Oh, it's got to be, well, okay, so when we measure, I have to think about it for a minute. Measure volts coming out of the wall, what do you measure it in?
Effective?
RMS.
RMS, effective. So why are you going to change it? Don't be changing it on me. You can just label it. Like a,
I was going to say, isn't it as long as you keep your measurements consistent throughout all the calculations?
that's what I was going to say. Or keep it consistent and label it. Apparent power, which is S. Now, sometimes in aviation, well, S's are made like this, like a little dollar sign. Because when you get into handwriting stuff, is that an S? Is it a 5? So S's would look like that. So S.
Just takes all the fun out of it.
I just took all the fun out of it?
Yeah.
I know, because, yeah.
You gotta sit there and be like, is that S? Is that a 5?
F5, and you try them all. All right, apparent power is the power consumed by the entire AC circuit. That's resistance and resistance and reactance.
Wait, I have a question. For true power, you said I squared R. Isn't
Yeah.
that the same thing as just voltage times I?
Yeah. But for some reason, I went with I squared R, and I don't remember exactly why. I think it's because, honestly, because one of the sources that I'm using preferred to do it this way. And I'm going to be honest with you. I had a real problem with your textbook and another textbook pulling out true power and apparent power. Some of them didn't make sense at all, and some of them didn't quite match. And I had to go through a lot of books and a lot of resources until I found the right one that laid it out exactly. Then I took that one and cross-referenced it back and tried to make sure that it at least didn't contradict anything else. And so it took a while. And so once I got it, I decided to go with what they said, how they said it, rather than risk saying the wrong thing. So sometimes I'll do it that way. So in this particular book, if they said I squared R, I just went with it. I'm like, yeah, I could change it, but I wanted this to be as simplistic as I could, and I think in a couple times I've given it, and it was a little too complicated. So I'm making it as simple as I can. So resistance and reactance. So that means if it's resistance and reactance, it's a function of what? What do we call the whole thing? Z, which is impedance. Okay, you guys are there. Right. This was kind of an interesting point, I thought. It is the product of volts and amps without reference to phase angle. So it is a product of volts and amps without reference to phase angle. In other words, it is volts. Back up a little bit because this one's very specific. V RMS times amps RMS equals apparent power. Apparent power. Or I square times Z. So P equals power apparent. The important point here will always be more than true power in a circuit, with impedance. It's 3 I's and then IV apparent power is expressed in volt amps, or VA, volt amps. And that brings me to power factor. You guys kind of caught up? So we have true power, we have apparent power, and then we have the power factor.
What's the stats?
Is that for me? Touchdown? What? All right. Back to this. All right, power factor. If you're just joining us at home, you're like, what was so funny? Never mind. All right, power for the ratio. It's the ratio of true power to apparent power. And the formula would be power factor equals true power divided by apparent power. Your answer will be a number between 0 and 1. Will be a number between 0 and 1. So what if your answer is 2? What's that? You're wrong. So 1 is a purely resistive circuit. And 0 is a purely reactive circuit. So no resistance, just reactive. And last point, the lower the number, the larger the phase shift. The lower the efficiency.
There's something wrong. Because
Is this going to be a question or just you trying to tell me I'm wrong? Okay.
If apparent power will be 0,
You're wrong, yeah.
I know. I love these. Go ahead.
which is will be 0.
What?
If there will be only resistance in the circuit and apparent power will be 0, you can't divide by 0.
Well, then I guess you got a problem, don't you?
Yes.
Oh well.
It will be never 1.
Huh?
It will be always 0.99.
See, I told you you're wrong.
The logic is
All right.
but
All right. Just to correct the authors of the book that wrote this, to make you happy, will be a number between. I'm going to have to write down here 0.0000000000000, and I'm just going to keep doing that for a long time. 1. So not purely 0, but slightly above.
It made sense the
That
first time.
I know. Everybody understood until I did that.
So what is that scientific notation?
Oh, I know. It's 0 times 10 to the infinity. Oh, would it be 0.1? 0.1 times 0 to the infinity.
it will limit.
Okay. Just relax. It's going to be okay, I promise. If you get to a math problem where it actually is 0, I'll give you the point, okay? And you can't divide by 0, I'll give you the point.
And would you divide by
You're going to be okay. So for the rest of you, like, what just happened? Don't worry about it, all right? It's just, when you go to engineering school for AC circuits, then you can start worrying about that. But otherwise, all right. Okay. Are you done with that? All right.
You guys tell me you're wrong? or-
What's No, everybody's good. Everybody's caught up.
You just.
Everybody's going to finish over conversations.
scientific notation?
Don't worry about it. All right, I was just trying to make up something stupid. So, okay. Here we go. So we got all that down because we're going to shift gears a little bit. We're going to put all this together now.
Yes.
Okay.
Worksheet?
Is Justin ready?
All right. So now this is going to be solving the problems. All right. So now we got to start solving these things. So
No, I'm good at that. I think.
let me see. Oh, I know what I'm going to do. We'll just try this. So what I'm going to do is, or you can do this, is basically just going to look, you're going to have a problem. Like I would always write before, resistors and all that. This time it's just going to be a set drawing where we have something that looks like this. And I'm not going to keep drawing this. Draw it once and you can kind of get the idea. So we have some information. Volts. Frequency. Resistance. 500 ohms. Inductance. 3.5 henries. And capacitance. 12 microfarads, FD farads. And given this information, you should be able to solve for the problem. We should find X of L, E of R, E of L, E of C, X of C, I total, Z, the power factor, power true, and power apparent.
Wait, did you give him?
Just I total.
Oh, you
Yeah.
didn't give him. Is that 3.5 what?
3.5 henries.
Okay.
Power.
Wait, what's the volts?
Volts and hertz.
I haven't given it to you.
What is it? Phase angle, right? After Z.
440. Oh yeah, I guess I didn't put that on here. Where's, oh yeah, and the angle of theta. So that's our goal here. What's my hertz? Hertz. 60. All right, is anybody freaking out? All right. Besides Tim. It's okay if you want to freak out, Tim. All right, let's work the first one together. I'm trying to decide if my example here is part of this or not part of this. I don't know, who cares? All right. What's my first step?
Start with X of L.
What's that?
X of L.
Start with X of L. Okay. So I'm going to have to scroll this so I can work with you guys. So X of L. What is my X of L? What is the formula for X of L?
2 pi frequency times
2 pi
induction.
FL. All right. So that's 2 pi. What's my frequency?
60.
60. And what's my henries? 3.5. All right, what'd you get?
1,300.
All right, 2 times pi times 60 times 3.5 equals,
1,000.
so X of L equals 1319 point. Now you have to be careful because we're going to do a lot of math stuff here. So don't, make sure you round appropriately. Don't stop there. Maybe go 2 decimal places. So 47 ohms. Okay, what's next? Okay, X of C. X of C equals 2 pi FC with 1 over. All right? So make sure you do this correctly. And the way I would do this is I would do everything under the line first, then hit the right key. So it's 2 times pi times 60 times, and this is the part that's very depressing for me to see how many people in this class just look at that number. And what was my capacitance?
Microfarad.
12 microfarad, and I can't believe, I think a third of the class is going 12. I don't know what that stuff is on the back, but I'll divide by 1,000, then I'll divide by 100, then I'll multiply by 1,000, and then I'll multiply by 10. And if one of those numbers looks like it should be, that's the one I'm going with. And I'm not joking because I'm scolding a lot of you for doing that. It's like, Well, there's my answer. That's not the right answer. Well, I'll divide by 1,000. There's my answer. Yeah, that's still not it. Okay, never mind. Let me divide by 100. How's that look, Kevin? Still not it. How about you just use the number 12 microfarad to begin with, and we don't have this problem? Yeah, I don't want to do that. Okay, then. You don't want to do that. I guess I got to let you be you. So x of c equals, what is this bottom going to equal now? So it's 2 times, I'm hitting the pi key, times 60. Oops, I think I just fat fingered it. 2 times pi times 60 times 12, the EE key. Everybody know how to find the EE key? All right. And if you don't, please say something now, okay? Just, it's no embarrassment. 12, and what is the mu, the micro? What is that?
-6.
Okay, so this calculator, I hit the 6, then the negative. On the other calculator, you get the negative first, then the 6. Equals, and I get a number that is 1 over 0.0045. Now, I'm just going to leave my calculator just like it is. I'm just rounding for you to look at it. And I'm just going to hit the 1/x key or the x minus 1 key if you have the other calculator. So I'm going to hit that, and I get 221. So x of c equals 221.05. All right, now what? Okay, x total. X total equals,
221.05 what?
yes. All right, xt, what's my formula for xt? X of L plus a minus x of c. All right, so xt equals, what's my x of L? 1319.47 plus a minus, which is the same thing as just saying a minus 221.05. So x of t equals 198.42. I'm not hearing much.
1098.
Yeah.
Yes.
There's no 1098. 1098.
1098. Oh, yeah, it says 109. Sorry. 1098. Yes. 109842.
Yeah, that's right.
Okay, next thing. Yes.
Is there any notation of it, like ohms or?
Yeah, ohms. Just get off me. What's next? Impedance. Okay, Z. Well, let's look at a chart now. So we've got, here's my chart, and what we've accomplished is we have x totals 109842. Now, because it's positive, is this an inductive or a capacitive circuit? It's inductive. Means there's more coil than there is capacitance. And that means that I've got a spot right up here that's between here and here. That distance is 1098.42. What is my resistance? How much?
500 ohms.
Okay, 500. There. And so we have to find Z, not to scale. So the formula for Z equals the square root of r squared plus x of t, correct? Square. Yes?
Yes.
Okay. Now, I'm doing this by memory. Some of you guys got to help me out here. I mess up, right? I want to know. Don't just let me keep going. That's not what you said before. All right, so the square root of 500 squared plus 1098.42 squared. All right, so the way I'm going to do that on my calculator is 500, hit the x square button, plus 1098.42, the x square button, equals, and that's going to be a pretty big number, 1456526.496. I'm just going to hit the square root symbol. And Z equals 1206.87 ohms. Am I correct?
Yes.
Yes.
All right. Okay. Now what? This is getting hard.
Phase angle.
Huh? Phase angle. Okay. So we got the phase angle, which is this part right here. And what did we decide we were going to use? Tangent, which is opposite over adjacent.
Something like that. Next.
Well, make sure I'm right. It's not adjacent over the opposite, is it? Is it opposite over adjacent? So, okay. All right, so I'm going to use that. So it's, oops, I'm going to put tan minus 1, actually. So that is the opposite, which is 1098.42 divided by 500. 1098.42 divided by 500 equals second tangent. So the angle of theta equals how much?
65.52 degrees.
65.52 degrees. All right, looking good. Let me see. Yep, 65.52. 53 actually, if you want to round there, but I would.
Excuse me, why you are using Z to
What?
to calculate?
Why did I use Z over here?
Yeah. You don't use Z, right?
This is impedance.
Okay, yeah.
This is impedance. This is the angle of theta. My phase angle. All right, now what?
You find the amp.
Oh, current total.
All right. Let's see here. Look, we'll scroll up here. We found x of L. We found. We didn't find those. Found x of C. Found Z. Found angle of theta. All right. What next? Want to go I total?
Sure.
Okay. So solve for I. What's the formula for I? Did I give you a formula for I? I total equals E divided by Z. So I total equals, what is E? 440?
Yeah.
Divided by Z, which is 1206.867, or 87, we'll call it 87. So 440 divided by 1206.87 equals, I total is
0.364.
0.36, we'll say 365, 0.365 amps, 0.365 amps. All right, so we got I. Now how about we solve for E of R, E of L, and E of C?
Those are all going to be the same. Right?
Well, let's see. E of R equals, what do you suppose that's going to be? I times R. Okay, I times R. Huh. That's crazy.
I didn't remember that.
How do we get that one? Okay, so E of R is I times R, so that's 0.365 times resistance, which was, I don't remember, 500. Okay, 500. So E of R is, this is 0.365. 0.365 times 500 equals 182.5. So it's 182.5 ohms for E of R.
Why ohms? It's volts.
I'm sorry, volts, thanks. Because I'm thinking about three things at once up here. Okay, E of R. E of L. E of L. Formula for E of L.
XL times
I times what?
XL.
X of L?
XL.
You would be correct. X of L. So E of L is 0.365 times X of L. My paper's messy. What is X of L? That's why I'm having trouble. I got 4 pages going here so I can keep track. X of L is, what's that? 1319469 times 131.47, right? 0.365 times 131.947 equals 481.
Yeah.
481.61.
Excuse me, how is possible?
No,
No.
Yes.
481.6. Yeah, 61.
How is possible that this voltage is more than like a total voltage?
I was hoping nobody would say anything until I got to the end. Okay, so he picked up on it. So what was my beginning voltage?
440.
440. And now we just got a voltage drop of 481.61.
Negative voltage.
It's negative voltage. We're making volts. It's the way it really is. Why? Because we multiplied it times X of L. And so you can, and I was going to show you this, we got to the end, I was going, wow, look at that. So let's add up the voltages in series and make sure it all works out. And I'm like, okay, so we've got 182 plus 481 plus, and you get this crazy number. Because of the phase shift and the way that it works, it doesn't work out. And that is totally normal. So it is an absolute crazy kind of a thing. And I think the first time I actually stand up here doing it, I'm like, oh crap, now what do I say? I had to think it through, but that's the way it is.
Wait, I have another question. How exactly?
I'm sorry, all questions need to be submitted in writing now. Go ahead.
How exact do you have to be? Because like I didn't round at all,
Yeah?
and I'm getting like 182.29, and then for that I got 481.05.
481 point, that's fine.
Oh.
So I have to hand grade it and on this part, and I'm going to know if you figured it out. If you got 180, now if you're like 180, 179, I'm like, you're just getting sloppy and so it's going to start getting progressively off. So you got to get it close, but I would accept 182 point anything probably. But you keep getting off, you're going to get off another one. All right, where are we now? E of R, E of L, EC. Okay, so E of C equals, guess? I times X of C. So I times X of C is 0.365 times X of C, which was 221.05. 221.05. 80.68 volts. E of C. All right, E of C. We got that one. Well, how about power? I got to move over. Power. All right, so I'm going to go true power. Power true. Power true equals I squared times R, so I have 0.365, if I remember correctly, times R, which I think was 500.
500.
Okay, so power true equals 0.365 times 500 equals 182.5.
No.
Nope.
I squared.
Oh, I squared. Ooh, boy, caught me on that one. 0.365 x squared times 500 equals 66. 66.61. Power true, power true, power apparent. Power apparent. So I squared times Z. So 0.365 squared times Z 1206. 0.87. Okay, so 0.365 x squared times 1206.81 equals
160.
what'd you get?
160.4.
160 point. I got 78.
Yeah.
What? Volt amps.
Volt, what? Volt amps.
Volt amps. So now we can do power factor,
Uh-huh.
which is power true divided by power apparent. And power true is 66.61 divided by power apparent 160.78. And what was your thing? What if we get a 0? It can't be 0.
Yeah, divided by
Can't. Of course
It's
not.
never gonna be zero.
But so we have a 0 there. We don't have to worry about it, do we?
41.
So 66.61 divided by 160.78. Oh gosh, please be a number between 0 and 1. 0.4. All right, so 0.4. 0.414. So power factor equals 0.414. We'll look at that.
No units.
It's just ratio.
That's just a ratio. And we did the phase angle already. I think we had everything, didn't we?
Yes.
Well, that wasn't so hard, was it?
No.
Time goes.
Okay, let's do this.
Hard part, we're looking for the formulas.
Hang on, I'm gonna do something here.
By the way, can we take a piece of paper with formulas on it?
Well, okay, so the question is,
Because
can you just can you have a piece of paper?
No.
Well, I would love to say yes, but
no.
there's a couple people in here who would just write everything in the world they could on that piece of paper. So no.
Can you write it on the board?
Yeah, you
Can
can
I,
write-
okay, so
why
let's
don't-
do this.
Why don't you just print out a little piece of paper with all the formulas?
So you can write more stuff on it.
Yeah.
We'll hand it out.
You'll hand it out during the test. How much can you possibly write on there?
Supplement.
All right, so you tell me what formulas do you think you're going to need?
I'm gonna say all of them.
Doesn't work that way. Now, if I'm going to write down what you tell me, but if it were me, I would want to see them in the order of which to do it. Like I wouldn't write the power factor as the first thing. I would probably do this in an order.
So
Excel.
Excel.
Okay, so the things you want to know. You want to know x of L?
Excel.
Okay, x of L, and that equals
2 pi.
2 pi
F
f
L.
L. Everybody see that okay?
Yes.
X of C.
Okay.
You just add an M in there, I'd be.
X of C equals
2 pi FC, and then,
2 pi f. Well, it sounds like you know it. Why are you telling it?
We're reading it.
Over 1. Now what?
X total.
Equals what?
L minus
Negative minus.
plus negative.
All right, now what?
Square root.
Square plus x total. Square.
All right, is it nice and neat enough for you guys? No, I'm serious. I don't want it to. Okay, now what?
Phase angle.
Phase angle.
And x of
Opposite over adjacent?
Yeah.
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 Okay. I total equals what?
E divided by Z.
E divided by Z. E divided by Z. Okay, now what? E of R equals
Pi total times R.
total. E of L equals
I
Phi total times x.
What's that?
I times XL.
I'm sorry, I can't.
I times XL.
Oh, okay, you're giving me the answer. Thank you. I total times x of c. What are we missing?
The phase angle, or no.
Phase angle's there.
Power.
Power.
True power.
Okay, power.
I squared times R.
Thank you.
When you write the theta,
R.
you should write the triangle too.
Power.
No.
Power.
Just bring a dictionary.
Power parent is
I squared
I squared
I
times z.
square
Z.
times
and the power factor equals
true power.
True
T over
Factor.
true power over parent.
power parent. Let me see. Power parent, power true, power factor, ECELERITZ x of all L. Well, that looks like everything you need to know.
Yeah.
Now, are we gonna have the test about if are we gonna have like efficiency and voltage efficiency and voltage max?
I don't understand
Like
that.
the formula is like 0.707 times E max.
Yeah, yeah.
Can we write those down?
Oh, okay. What do you want me to write?
Write everything on there.
It's like peak to peak equal
I got the formula.
2 times peak.
Nice.
No,
Just
E-
taking up space.
efficiency.
Erase everything.
We gotta start this all over.
Face the wall.
E effective equals 0.707 times E max.
Hey,
And then E max equals 1.414 times E effective.
I still don't know where you got
there. All right, is that good?
Average voltage.
No.
It's backwards.
And it's interchangeable.
Just for safe current.
Just for safety.
But F equals volts.
F equals volts. I should probably just put this.
Yeah.
That does
Don't forget pi.
Huh?
Don't forget pi.
Oh, yeah. Well, we got all that. Okay. All right, so you guys have all that.
We get the Pythagorean theory.
The Pythagorean theorem. Where is the It's on here. Where is it? Z, it's already there.
Z is Pythagoras.
Yeah. Okay.
A squared plus B squared equals Z squared. Okay. Well, I guess the only thing to do is do another one, right?
Yes.
Okay. Let me see.
Let's do it with more than x of r.
Try and give you one that's not. Okay, let's try this one here. All right, so just to be clear, this is the exact. I'm going to save this, and I'm going to have this up tomorrow, okay? Or I'll write this on the board or something like that.
Leave it up right now.
Okay, I can, but I can't write anything else.
You can give Expo marker.
He's got a good point. I'll just start writing right about here.
Let's start tomorrow.
All right, you should have a piece of paper right now that you can work with. It looks just like this.
I'm saving trees, alright?
But you know how I feel about trees. I hate them because they suck up all the oxygen.
What? Is that why you play a plane?
I don't see a correlation, but
They don't suck up oxygen.
I think they do.
They breathe out oxygen.
They bring in CO2.
Now you love trees.
Now you love trees.
You guys are making up stuff. Okay, just because we're recording it for the record, yes, I know, trees don't. But it's fun to say that, to see how people go, are you sure about that? Pretty sure, yep.
How much glue did you put in your coffee today?
All right. It's not so much the Kahlua that gets me.
Jameson?
Now, since I would get in trouble for having a bottle of vodka here, I just drink my hand sanitizer. I call it soap teeny.
It's apple. Apple's flavored hand sanitizer.
Uh-oh, I don't know what's the given here. Okay, I guess we'll go.
We don't need it.
60 hertz. 220 volts. 200 ohms. 1.5 henries and 5 micro farads. That's all you need right there. Now, you want me just to let you work it out on your own?
Yeah.
All right. Tim's already, he just pooed. What? All right, so I'm going to pause.